Welcome to Breville Institute of Actuarial Studies. Now we are discussing about transition matrix and transition diagram and transition probabilities. For that, we are considering one time homogeneous Markov process. Time homogeneous. That means time will be always same for each transition. Time will be same. So we can say time independent. So time homogeneous means time independent. So we are not considering time for each transition. And time homogeneous and time inhomogeneous, please visit my old videos. For example, we considering one square matrix. Square matrix will be 2 into 2. That means rows and columns are same. 2 into 2 matrix or 3 into 3 matrix, like that. So we calling transition matrix. Considered one square matrix 0.6, 0.4 and 0.3, 0.7. This is the one square matrix. This is just one example. This is one square matrix 0.6, 0.4, 0.3, 0.7. How to write this transition matrix? From how to write transition probabilities, how to extract these values to transition probabilities. We already learned how to write a transition probabilities in previous videos. So how to write this transition probabilities? This how many states are there? 1 and 2. Here 1 and 2. So we have 2 state, 1 and 2 only. We have 2 state. This one transition probability we will write P of 1 1. What means first one is a row and second is column. So P of 1 1. This is the P of 1 1 and P of 2 1 2. So this one is the P of 1 2. What will be this value? This value will be P of 2 1. So next one. What will be this value? This value will be P of 2 2. So P of 1 1 is equal to 0.6. P of 1 2 is equal to 0.4. P of 2 1 is equal to 0.3. And P of 2 2 is equal to 0.7. So we transition matrix, we return the transition probabilities. P of 1 1, P of 1 2, P of 2 1, P of 2 2. So we learned the transition matrix. This is one just example, and we return the transition probabilities. Next, how to represent this transition matrix? How to represent in the diagram? So we call transition diagram, transition graph diagram. So how many states are available? 1 and 2 states. So we have only 2 states. So this is the first state and this is the second state. We have only 2 states, 1 and 2. So transition from P of 1 1 means we are in the state of 1, initially in the state of 1 and not moving to any other state. We stay in the same state. What is the probability? 0.6. So we are in the state 1 and we not moving to any other state. We are in the state 1, we are not moving to any other state. This is called P of 1 1 and it is a 0.6. P of 1 2 is a 0.4, moving from 1 to 2. This is 0.4. P of 1 2 and P of 2 1 is 0.3. P of 2 1 is 0.3. This is P of 2 1 is equal to 0.3. And P of 2 2. P of 2 2 means we are in the state of 2, continue in the same state. Continue in the same state, 0.7. So what's the meaning of P of 1 1? We are in the state of 1 and continue in the same state. P of 1 2 means we are in the state of 1 and moving to second state. And P of 2 1 means initially we are in the state of 2, or we are in the state of 2, we moving to 1. That probability is 0.3. And P of 2 means we are in the state of 2, continuing next transition also, there is no change. We are continuing the same state. So we learned about transition matrix, transition probabilities, and we draw the transition diagram. Next one, on 2 points has to note down this Markov process. Markov chain or Markov, this transition matrix, the sum of the each row should be 1. Sum of the each row. This is the sum of each row, Pij, j element of S. We call this is will be 1. This one will utilize in the our calculation. P of ij is equal to 1. That means this is first row sum is equal to 1. This is also equal to 1. So what is the meaning? First row 0.6 plus 0.4 is equal to 1. So it's a transition. It's a Markov process. And the next one 0.3 plus 0.7 is equal to 1. This is one of the condition in the Markov process. 0.6 plus 0.4 is equal to 1. No? This is also equal to 1. So this two row sum of the each row is equal to 1 only. So this point has to note down. Please note down this point. This is we required in the our calculation. Next point, how to write the matrix multiplication. Matrix multiplication we already learned in the graduation classes, but just we are showing how to multiply the matrix. So here they will ask one step probabilities, two step probabilities, like that. So how to represent this one? This one is Pij. One step probability will represent like that only. And sometime it will ask 2 times. Sometime will ask Pij is to 2. So this one will be, we can represent like that. Pij. Sometime they will represent like that. This means it's a power of matrix. Power of matrix means P square. How to find the P square? P square is equal to P into P. P square is equal to P into P. We have a matrix value. We have a values. We have to find out the P square is equal to P into P. So we have P is equal to, our P value is equal to 0.6, 0.4 and 0.3, 0.7. This is our P value, and multiplying to same value 0.4, 0.3, 0.7. We multiplying the same value. So matrix multiplication, we always think about a 7 rule. It's a first row will multiply to first column. This is like that only, will multiply like that only. It's a 7 rule, 7 model. First row is multiplying to first column, first row is multiplying to second column. So 0.6 into 0.6 plus 0.4 into 0.3. So this first row is multiplying to first column, then first row is multiplying to second column. 0.6 into 0.4 plus 0.4 into 0.7. Another one is multiplying to second column. 0.3 into 0.6 plus 0.7 into 0.3. And second row is multiplying to second column. 0.3 into 0.4 plus 0.7 into 0.7. These are the values. Please note down that values. These are the values. Please note down these values. These are the our values. Also P square is equal to what is the values of P square? P square is equal to 0.5 4, 8. This is you add some, please add this all sum. You will get 0.48, 0.52 and 0. This one 39 and 0.61. This is the p square. So add this one, we will get the p square. So matrix multiplication we already know in the graduation. So please refer our videos for more matrix multiplication and practice questions. Please visit my website Braille Institute. We calculate p square. Sometimes they will ask, what they will ask, p cube, how to represent p cube, p of ij and cube. This we can write, sometime we can write like that also. This what is the meaning? P square into p. P square into p. So p square into p. P square we already received into p. So this matrix calculation, please, p square is equal to, p square we already received, p is available here. So this is the 0.48 and 0.52 and 0.39, 0.61 is multiplying to p, 0.6, 0.4 and 0.3 and 0.7 is multiplying to p. So again the same rule, we multiply this ones to here, 0.48 into 0.6, 0.52 into 0.3 and this one to here, 0.48 into 0.4, 0.52 into 0.7. This one please calculate in your books. You will get the answer. Answer will be 0.444, 0.556, 0.417, 0.583. We will get the answer. This is the p cube. So we understood Pij raised to 3 means this is power of matrix 3. How to calculate p square into p. We understood the matrix multiplication, transition matrix, time homogeneous. What's a time homogeneous? It is a time independent. We are not considering time. That is our benefit in time homogeneous. So p square, we received p and we return the transition probabilities p11, p12, p21, p2 and we draw the transition diagram. Later we learned matrix multiplication. So these three things we keep in the mind. Next we considering one problem. For more problem, please visit my videos and my classes and join our classes. Visit our website. How to join our class is available in our website. So next one example, we considering one example. One Markov process with a state space 1, 2, 3. 3 state space available. Markov process. It is a Markov process and state space are 1, 2, 3. Transition matrix with the transition probabilities P, Q, 0, 0.5, 0, 0.5, P minus 0.5, 0.7 and 0.2. This is our transition matrix. So state space, what are the state space available? 1, 2, 3. So these are the state space. This is a square matrix, 3 into 3 square matrix. So 1, 2, 3, 1, 2, 3. That means 3 rows available, 3 columns are available. In this square matrix, so first question, find P and Q. So first question, find P and Q. It's one of the Markov process and the state space are 1, 2, 3. First question asking about find P and Q. So we know that in the Markov process, each row, sum of the each row is equal to 1. In Markov process, sum of the each row is equal to 1. So P plus Q is equal to 1. So this one is equal to 1. This sum of this row is equal to 1. This row is equal to 1. This row is equal to 1. So P plus Q is equal to 1. And we consider third equation, third row. P minus 0.5 plus 0.7 plus 0.2 equal to 1. So P is equal to, solving this equation, this we can say 1, this is 2, second equation. Solving this equation, we will get P is equal to 0.6. We have to substitute this value in P plus Q, Q is equal to 0.4. So what will be our matrix? Our transition matrix P is equal to, we are substituting P and Q values 0.6, 0.4, 0, 0.5, 0, 0.5, 0.1, 0.7, 0.2. This is our matrix. We find out P and Q with one of the feature of Markov process, sum of each row is equal to 1. Second question, transition diagram. How to draw the transition diagram from this transition matrix? This is a 3-state space matrix. How to draw the transition diagram from this matrix? So we have a 3 state. So 3 states are 1, 2 and 3. This we have a 3 state, 1, 2 and 3. So transition is happening each state to other state. First one is the 0.6 is, this is a first row, first column, third column, 1, 2, 3. So this one will be P11, this will be P12, this will be P13 and this will be 21, 22, 23, this one 31, 32, 33. So initially we are in the first state and continue in the same state 0.6. Initially we are in the first one. This is a P of 11. Initially we are in the first state, continuing the same state. And P12 we are moving from first state to second state. This is 0.4. And P13, there is no transition from the 1 to 3. Next is second row, considering second row, P of 21. So it's returning back. P of 21, 0.5. And P of 22 is equal to 0. So nothing is staying in the same state. And P of 23 is equal to 0.5. Next one, P of 31. P of 31. So P of 31 is equal to 0.1 and P of 32, 32 going back at 0.7 and P of 33 is staying in the same state 0.2. This is our transition diagram. So we find out P and Q, then we return the transition matrix and converted transition matrix to transition diagram. What's the usage with this transition diagram? We understood how the transition is happened. So it's easily we can understand how the transition is happened. So more about these problems, so kindly visit my website www.bravelinstitute.com and subscribe my channel. Thank you.